All right, everybody. Well, now we are going to move on to descriptive statistics, the basics of them, at least. So, before we get going, I want to just briefly talk about something we're going to talk about more in class and more later in the semester. But just what's the point of statistics? Just take a second to think about that. There's a reason you're in this class. Well, really, the point of statistics is to, in essence, summarize what is going on in your data. Right? The reason we use statistics, we look for numbers, is because we don't want to just look at a group of people following, let's say they go through some treatment for depression, and then just come up with, on our own, a decision about whether or not it worked. No one would do that. We want numbers. We want evidence for it. So what we're going to do in all of these cases is we're going to take kind of real world problems and we're going to look at the numbers behind them to see what the numbers say. And that's the point of statistics. It's to summarize data. So statistics and what we are going to be doing, it's that we're going to be using tools to try to figure this out. And we are interested in the statistics that we have here, primarily the measures of central tendency and measure of variability, because we're looking at certain types of data. And so we will see how together the statistics that we look at today, the two different types, are going to kind of work in tandem to describe our data set. All right, so we are going to look at measures of central tendency first. There are three of them: mean, median, and mode. And then measures of variability: range, variance, and standard deviation. Now, some of you are going to be looking at this and think to yourself, I already know all of this. I have no doubt that some of you know how to do the math behind this, but we're going to be looking at these in much more detail than you probably have done before, and honestly, probably more than you want. But let's get to it. So first, what are measures of central tendency? And you need to know the difference between measures of central tendency and measures of variability, why they are grouped together. So measures of central tendency that we will be looking at, there are more than just these, but the main ones we are going to be looking at are the mean, median, and the mode. What are these things? Well, they are really just single values that are attempting to represent the middle or the center of a data set, trying to describe a data set that we have, but what's going on kind of in the middle, what the average person is having, how much a typical person is getting or doing or has. So, for example, the mean, median, or mode of income in a city represents what exactly? Well, really, it represents how much a typical or an average person makes in a specific city. It doesn't mean that it is perfectly representative of everyone who lives there, but it's a decent idea of where our data are. So this is going to be true for both all the mean, median, and mode. All three of them are looking for approximately, as just a basic way to look at it, how much of something there is. It's a decent, it's not completely accurate, but how much of something. How much income does someone have? How much happiness? How depressed are people? But across a data set. So we can't get mean, median, and mode for any single person. There's no reason to say that I would have an average for happiness unless we had multiple measures over a series, a group of data points. But for the most part, we're looking across people, across measurements in a data set. All right, so let's get to it. So we're going to start off talking about the mean. The mean oftentimes is interchangeably used with average. We're going to stick with mean though. And the way that we're going to denote the mean is a bar on top of whatever our variable's name is. So for example, if we have on the slide, you can see capital A bar, A bar. Well, that would just be the average of whatever variable A is. Or for E bar, that would be the average of whatever variable E is. Think of any variable you want. Happiness. Let's say then the average of happiness could be H bar. Anything you think of that there's a bar over it, it means average. Now, how do we calculate the average? Well, some of you already know how to do this intuitively, but might not know the formula for it. So, the average is the sum of A, and here already we can see the summation sign come up, the sum of A divided by N, where N is the number of scores there are. The number of, generally speaking in psychology, it's the number of people in a data set. Now, while we have A bar and E bar, or whatever bar, for a population, and I'm putting this here so when you come back to reference this slide, this is here, but for a population as opposed to a sample, which again we'll get to later, the symbol is actually mu. This is a Greek mu right here, the one that kind of looks like an odd M, and it's pronounced mu. But we'll, again, get back to that later. And we've already talked about the Greek symbol of sigma. So in this case here on the screen, sigma A means you add up all of the values for A. So now that you have a little bit of an idea of what mean is, let's go and do an example. So, as with past examples, just go ahead and pause the recording, then calculate it, and then start it up when you are ready. All right, hopefully you are good. So, when you add up each of these values, 1 plus 1 plus 3 plus 3 plus 3 plus 3, etc., you would get 64, and there are 20 total values. So 64 divided by 20 is equal to 3.2. So if we had a group of religiousness scores, these ones that you can see, the mean would be 3.2. So I said that we're going to get into more detail than you probably wanted. I know we haven't done that so far. We will shortly. We will be returning to this. But as of now, if you feel comfortable calculating the mean, we're good to go. So let's move to the second, and that's median. So the median, or you can have MDN as the abbreviation, that's the score that divides a frequency distribution in half. Now, what's a frequency distribution? Well, it's just if you were to arrange all of the variables, or I'm sorry, all the values in order, the median would be the middle score. So the frequency distribution is just all the scores arranged in order, and the median is the middle of there. So on the screen, you can see with odd numbers, this is pretty easy. So 5, 10, 20, 25, 30. Because these are in order, we don't have to reorder them. We can just say, okay, we don't need to worry about 5 or 30, 25, 10, 20 is the middle number. So the median in this group of numbers is 20. Now with even numbers, the median is the average of your two middle scores. When you have an even number, you're going to end up with two middle scores. So 5, 35, 30, 10, 20, and 25 are two middle scores. So 20 and 25, the average is 22.5. Hopefully, calculation is fairly straightforward. So let's give it a shot. So what is the median of happiness in our sample? And as always, pause it and resume when you are ready. All right, so if I were you, I would reorder all of our numbers to numerical order. You say, okay, we got 1, 5, 5, 1, 3, 3. We have two 3s in the middle, and the average of 3 and 3 is 3. So the median of this happiness sample is 3. Wonderful. So let's move on now to talk about our third, and that is mode. So the mode is the most frequently occurring score in a set of scores. So we're not really going to be doing math here as much as counting up our scores. So in this first example, we have two 5s, 1 10, two 15s, 1 20, and three 25s. The mode here is 25. If you have two two values occurring the same number of times, that's where it gets a little complicated. And I mean, by a little complicated, I mean not very complicated at all. So we have 3 5s now, and we have 3 25s. So what's the mode here? Well, some people will tell you that there is no mode because there is no value that only occurs the most, no single value. Other people will say both 5 and 25 are the mode. I personally am inclined to say both 5 and 25 in this case are. So when we have this situation, if you just say the mode is equal to however many numbers, there could be 3 or 4 or 5 or however many numbers that occur the same number of times, just say all of those are modes. That's good for us. Now, because this is so basic, mode is oftentimes not particularly useful, but it is sometimes. So when we are looking at, let's say, votes for an election, we aren't really interested in the average number of scores. That doesn't really make a whole lot of sense. So mode is useful when you simply want to know which score has occurred the greatest number of times. So who got the most votes? That is looking at the mode. So let's look at this example here, the mode of happiness. So go ahead, pause, and then resume when you are ready. All right, well, let's count them up. So we have 5 happens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times, and 3 occurs 1, 2, 3, 4, 5, 6, 7, 8 times. So we have 10 5s and 8 3s. So 5 is our mode. Wonderful. All right, so these hopefully have not been that difficult now, up to this point. But now we're going to get into something a little bit more complicated. So let's say that here we have this set of income scores from somewhere. Doesn't matter where it is, say a neighborhood. What would be the best to use in this case, in this data set? The mean, the median, or the mode? Well, one good way to see what the best is to calculate them. So what I want you to do now is pause the recording, calculate the mean, median, and mode for each of these for this set of scores, and then try to come up with an idea of which one of these 3 is the best to use. Which, if I were to ask you to describe this data set, because remember, that's what we want statistics to do. We want statistics to describe our data set at this point. Which one would be the best? So go ahead, pause. All right, so let's just first go through what the answers are. So the average income in this distribution is $63,647. The median income is $8,000. And the mode is $1,000. So you can see these 3 give us very different ideas of the same data set. We're describing it very differently. In one case, the mean, it says 63,647.1 is our description of the sample. If you were to live in a town or a neighborhood that had an average income of 63,000, you might be fairly happy with that. At least, I'm pretty sure you'd be more happy than if you lived somewhere that had a median income of 8,000 or a mode income of 1,000. But then again, those are all true for this. So which one do you use? Well, there are some pros and cons to using each. So, for example, the 1,000 in this case, 1 million income really throws things off. Without the million, our average income goes down to 5,000. So, what should we do? Well, this is a case where we can look and see what the situation is with each of our measures. Because again, all of them are right. It's just some of them are not as good description of our data set. So when do we use them? Well, first of all, the mean is the only measure that we have used here, mean, median, and mode, that actually reflects each score in the distribution. So every score that you have impacts the mean. If you took one away or added one, it would change. Well, unless, well, we don't need to get into that. It is most of the time going to change. Now, this is possibly a good thing because it takes everyone into account, or every score into account. But on the other hand, it's also the most extremely affected by our extreme scores. So in the last slide, we saw that you add the million in, you have 63,000 as an average. You take it out, it's 5,000. So the mean is good in some ways, but it's also affected by extreme scores. The median, on the other hand, that is only concerning the number of scores above or below the median. It's not actually all of those scores above and below don't get taken into account when you get the number for median. But it's good when mean is bad, truthfully. If the mean is affected by extreme scores, well, medians are not really affected by extreme scores under most circumstances. So if your distribution is skewed, or you have extreme scores and extreme outliers, the median might be a good thing to do. So if we look back, here in this distribution, we have our mean of 63,000 and our median of 8,000. You could make the argument to me that 8,000 is the better description of the data set because it seems to be actually more representative of everyone in the data set because there is this big outlier. However, if you wanted to say that income influences things like taxes, and you need to take into account everybody's scores, then you might want to include the million in there. And then finally, the mode. Well, the mode is really only suitable when you want to know the most commonly occurring value. There are a certain type of scores that we'll talk about in SPSS called nominal scores, though you can't use mean and median for them. So those are categorical variables. You can't take the mean of 5 men and 2 women. How do you get an average from that? But you could say there are more women than men. There are 5 women and 2 men. So the mode, honestly, this semester we're probably going to be ignoring it more often than you would think, but it's an important one to know, have an idea of where you're going. So when do we use each of them? Well, in my class, we are going to be using each of them all the time because each of them gives us something different. And if our goal is to describe data accurately, we need to take into account all of the different ways we can describe it. And for me as a scientist, you want to let people decide. If you tell someone that the mean is 63,000 and the mode is 8,000, that's a lot better than telling them just that the mode is 8,000 or just that the mean is 63,000. Let the people decide what's important, or give them a better, fuller description of what's going on in your data set. All right, so that is the mini lecture on measures of central tendency. We're going to move on to measures of variability. But again, remember, at this point in time, if you should be good to move on if you are able to calculate each of the 3 of them and you have a decent idea of when they do what they do. And then finally, knowing what measures of central tendency are broadly. So, assuming you've got that and you feel good, let's move on to measures of variability. So, measures of variability. Well, one of the ways we can show what measures of variability do is by giving an example. So let's look at this example on the slide. So let's say we have classroom X, and classroom X has these 5 scores: 160, 130, 170, and 40. And classroom Y has 102, 101, 199, and 98. How would you describe these data? Well, so far the tools you have are mean, median, and mode. So let's look. Well, the mean in our data set here is 100, and the mean in our data set here is 100. The median is also 100, the middle score in each of them. And the mode, well, there really isn't a mode because no score happens more frequently. So according to our measures of central tendency, these 2 classrooms are exactly the same. But are they really? So what is it that is being demonstrated here? Well, if you look at it, you can see that the scores for classroom X are more spread out, more extreme, both high and low, than the scores in classroom Y. Well, this is exactly what measures of variability do. They indicate to us how spread out our data is. It also can indicate how representative the mean is of your data. And we'll be talking about that more when we talk about models. But for now, just know that the really measures of variability are looking at how spread out our data set is. So first up, let's talk about range. Range is our simplest measure, and it is simply the highest score minus the lowest score. So for classroom X, 160 minus 100, minus 40 equals 120. Whereas for classroom Y, 102 minus 98 is 4. So you can see from that alone that classroom X has more spread out scores than classroom Y. So the problem with range is that it is very sensitive to outliers. It's actually even more sensitive to outliers than mean is. If we look at our data set as it currently is on the screen, we have a score of 1 million all the way down to 1,000. So if you take the highest score minus the lowest score, we have 999,000 as a range. If you take it out, so it's only 10,000 to 1,000, you have a range of 9,000. So by taking out this one score, you have a difference of 990,000. That should just hopefully underscore to you how sensitive range is to outliers. So what, in our example, is range here? I'm not even going to ask you to pause it, because if we have a scale from 1 to 5, we can see our scores only go from 1 to 5. This should be the easiest math you do all semester. We take our highest score 5 minus our lowest score 1, and we get a range of 4. Truthfully, range is most of the time fairly useless because it is so sensitive to outliers. It's not something that is oftentimes reported in papers. Truly, the best time that range comes up is when you are dealing with data sets such as SPSS, and you can just check to see if you've accidentally entered something. So let's say in the example on the screen, instead of 1s and 3s and 5s, we had this score here be 55. Well, then we could run our stats, and you would see, ooh, on a range from 1 to 5, the range is actually 54. That doesn't make any sense. So we're not going to be using it a whole lot, but it is actually pretty useful when you are running statistics. All right, now we're going to move on to the two most complicated ones, and the ones that I'm sure we are going to spend a lot of time going over in class. So the first one is variance, and you're going to notice that the notation changes over time here. We're going to get more complicated as the semester goes, but I just want to get your feet wet right now. So variance, the notation we are going to see most often this semester is SD squared, and we'll talk about what that means in a little while. Variance conceptually is the mean of the squares of deviation scores. What does that mean? Well, you can see here that we are actually going to have two different formulas. We have one that is for a sample, and we have one that is for a population. The only difference you're going to get is that one of them is n minus 1, and one is n. And we will talk about the difference between s and s squared, this sigma squared, SD squared. We'll talk about that later. Don't worry about it for now. Just trust me, we're talking about the same thing. So for a sample, which again we'll talk about later, we have this equation. For a population, we have this equation. I will give you both of them on the test. However, you should know, just off the bat, we are only going to be doing samples unless I say otherwise. So on a test, if I give you 10 numbers, say what's the variance, you will use this equation, unless I say what is the variance in this population. So assume a sample. All right, let's walk through this equation fairly slowly, shall we? So Variance is equal to the sum of x minus x bar squared. Well, hopefully, if this is scaring you, you think back to the first lecture that we went over, the basic math review, and you say to yourself, well, maybe I should do what Dr. Longo said, and I should put PEMDAS at the top of my screen, or top of my paper. If you did, you would know that we have to do parentheses and exponents first. So we have to do the parentheses in here. Then we'll square, then we add up, and then we divide. So we now know we have to get x minus x bar. And this is the first complication that you will have this semester. And that is that, just as I said previously when talking about summation, when we say the sum of x, we don't mean one value. We mean all of your x scores. And so you will be doing this individually for each one. So let's take a look at how we're going to do this easily. And how we're going to do this easily is by making a chart. I will give you the equation on the test. I will not give you the chart, but you will be able to make the chart from the equation if you give it enough time and if you think through the equation with me. So let's walk through this. So what I say to do first is put the values, whatever I give you. If I say, what is the variance of these 10 scores? You'll have 10 scores in this value column. Then you're going to add them all up and then get the average for that score. So you will have your values, however many of them there are, will go in this first column, and you will get the average for them. So we have our x scores so far. We have each x score. Then we are going to subtract, well, we need to get the average. We just did that. So we will put average in this column, the same number in this column, all the way down. Then we know we need to do x minus x bar, x minus the average. Well, that's what the difference is. X minus x bar equals the difference. Then we will square it, square this difference score. So this value squared, this value squared, this value squared, this value squared. Then we know we need to add them all up because that's what summation says. So we add all of our scores up. And then the last step is to divide by n minus 1, or n if it is a population. But we'll talk about that more later. So let's see what this is worked out. So let's say we have 4 values. Well, we have our 4 values. We sum them up. We get the average. We put the average there. Again, the average will be the same for the entire column. Then we'll take value 1 minus the average, value 2 minus the average, 3 minus the average, 4 minus the average. Then we will square. So we've already done x minus x bar. Then we'll square them. So x minus x bar squared, x minus x bar squared, x minus x bar squared, x minus x bar squared. Once we've completed this portion, then we add them all up. So that plus that plus that plus that is the sum, and we're left dividing by n minus 1. So in this case, there are 4 values, so n would be 4, so we divide by 3. Well, let's look at an actual example with real numbers now. So let's say you have these 4 values, 5, 4, 6, and 5. What do we do here? Again, let's just pretend you'd seen this for the first time. We know we need to do PEMDAS. So the first thing is, what are our parentheses? Well, we have x minus x bar, so we know we have to calculate the average. So we have all of our x scores, because I'll give them to you. You add them up and divide by the number there are, divided by 4. So 20 divided by 4 is 5. So we know the average here is 5. So we put 5 across the board. Then we have to complete what's in the parentheses. We actually have to do x minus x bar. So 5 minus 5 is 0. 4 minus 5 is negative 1. 6 minus 5 is 1. And 5 minus 5 is 0. So we have now completed our x minus x bar. Now, PEMDAS. Remember, exponents come before addition. So we're going to square each of these values. So 0 squared is 0. Negative 1 squared is 1. 1 squared is 1, and 0 squared is 0. So we now have taken x minus x bar. We've squared all of them. Now we need to add them all up. So 0 plus 1 plus 1 plus 0 is 2. And then you divide by n, or n minus 1. In this case, we've done n. And so 2 divided by 4, the 4 values there are, is 0.5. If you wanted to do it by a sample, which I've told you is what you are going to default doing, it would be 2 divided by n minus 1. There's 4, so 4 minus 1 is 3. So it would be 2 divided by 3, so it would be 0.66. We are going to go over this a painful number of times. I'm going to give you tons and tons of different examples. If you are already feeling overwhelmed, don't worry, come to class and we will work through them. There are also example problems on Canvas if you would like to check them out. Or I would suggest rewind this lecture a little bit and walk through it again. If you are feeling good enough to try a sample problem, let's do it. Let's check and see if we can find the variance of happiness in this sample of scores. Well, the first thing, you're going to have the equation. You're going to have some numbers I give you. So I would write PEMDAS at the top of your paper, and then you need to make your equation. You need to make your table. You have your equation. So let's take the equation and make our table. We know we need x. So we have x's. We need x minus x bar. Well, you need your x bar. This is x minus x bar. Then exponents come before addition, so you square each of these scores. Then you add all of them up. And then you divide by n minus 1, especially because I told you it's a sample. So if you're feeling good, go ahead and make your variance table using all of those values in it. Once you've completed that, you can pause, I'll tell you the answer, and then if you're still having issues, we can go over it in class. All right, so if you have worked this out, you can hopefully, if you have done it correctly, the answer is 2.48 or 2.49, depending on how good you were at rounding. So 2.49, if you're having issues at this point in time, I want you to just calm down, come to class, and I'll help you through it. Now, if we had a population, instead of n minus 1, as we had here, it would be n. So instead of dividing by 9, we would divide by 10. And so I'm on the last step. And so we would have a sample variance of 2.48 and a population variance of 2.24. So now is the point where I'm going to tell you the difference between sample and population. Because really, up to this point, I've only cared if you can get the math. But now you should probably know why there is a difference between them. So when we are talking about samples and populations, it's important to know the difference between them. So when we do a study, we want to pool from our population. And our population is any person who could possibly be in the study fitting whatever kind of inclusion criteria we have. So let's say we want to do a study looking at income in people over the age of 18 in the state of Alabama. Well, in that case, our population is every person over the age of 18 in the state of Alabama. Now, in research, we almost never get to study populations because it's so hard to get them. Truthfully, it's even hard for me to get a population estimate on tests because almost every test, someone doesn't show up for it. So I can't even get every person in my class to do something. Can you imagine how hard it would be to get every adult in the state of Alabama to do something? Well, that's why we turn to samples instead. So samples are subsets of our population. It's whatever we can get or whoever we can get our hands on. So if our population is the state of Alabama, of people over the age of 18, our sample would be just whoever we can get who is over the age of 18 in the state of Alabama. So you could have, let's say there's 5 million people in a given population. Your sample could be 2 or 3 or 4 or 100 or 1,000 or almost everyone in it. But it's so hard to get it that we turn to samples as opposed to assuming we're going to get populations. And this is the reason I told you that you can assume you are going to be looking at samples instead of populations, because we almost never deal with populations in statistics. So we'll talk more about it in class, but that's a little bit of a primer. All right, next up is standard deviation. Standard deviation, you probably have heard of more than variance. If you've read academic articles, you probably have seen it before. Standard deviation is kind of surprisingly simple in that it is just the square root of the variance. Literally, that's it. So if we have a variance of our population is 2.48, well, the standard deviation is just the square root of 2.48. So you do the same chart, you do the same math, you do the same everything, and simply square root your variance. So not a whole lot that's that difficult in here. It is, for most people, going to be one button on the calculator. So a reasonable thing to say would be, why do we have that? And we'll get to that in a second. But I want to point out some of the notation issues, because just like how I was concerned about the math earlier, I'm primarily concerned about that, but want to show you some of the notation. So standard deviation versus variance. Standard deviation, if you think about it, makes more sense. That SD is standard deviation. Variance is SD squared, because, as we just saw, standard deviation is just the square root of variance, and therefore variance is the standard deviation squared. So standard deviation is SD, and variance is SD squared. If you use that notation, I'm fine with that. However, you will also see, if you look in your book, if you look for help, there will be other notations. So SD, standard deviation, is also just italicized capital S. So S is equal to standard deviation. And also this sigma is standard deviation. Whereas this S squared is variance, this sigma squared is variance. And yes, this is lowercase sigma. This is when I said at the beginning of the semester that learning statistics is kind of like learning a foreign language. This is kind of example 1A of why it is. There are things, multiple symbols for the same thing. If you are annoyed by this, I feel your pain. I am annoyed by it as well. But again, you're going to have to memorize that SD equals standard deviation, SD squared is variance. SD makes sense. So standard deviation makes sense. There's no V, right? V would be the one that would make sense for variance. It's not there. So remember, SD, standard deviation, SD squared, variance. All right, so I mentioned this previously, but why do we have both variance and standard deviation? They tell us almost the exact same thing. Well, truly, we almost exclusively use standard deviation, and that's because standard deviation is in the same units as the original measurement you've done. Remember that variance is SD squared. Well, in variance, you square your units. Therefore, if you were to have, let's say you had height and you had a variance of 4 inches squared, that's what the units are going to be. It's not going to be a variance of 4 inches. It has to be inches squared. So if you square root your variance, you get standard deviation in the same units as the original. So that's kind of number one why we do it. But number two is that we're going to see standard deviation pop up a lot over the course of time. This is an example of a normal curve, which we're going to be getting to very shortly. But normal curves use standard deviations for reasons, again, we'll talk about then. But variance is also used in some other statistics. You will see that variance is actually used in our t-test equation, but for reasons we don't need to get into right now. But there are reasons for both of them. Right now you might not understand them, but try to trust me. It'll make sense over the course of the semester. Okay, a couple more brief. All right, so let's move on to bringing both measures of central tendency and variability together. So let's say we have a data set that has a mean of 15, a median of 10, a standard deviation of 3, and a variance of 9. What can we infer from this? What can we learn? Well, one of the things that we saw earlier was that when means are higher than medians, you can have a skew or a high outlier. So remember that when we had that score of 1 million, that pulled the mean up a lot, but didn't do a whole lot to the median. So in this case, if you have a mean that is higher than a median, you could say there might be an outlier that's high. What it is, we can't tell from this, but that could be a reasonable thing to infer. Let's add in a second data set, and where we also have a mean of 12, a median of 10, a standard deviation of 2, and a variance of 4. Well, in this case, we can say we almost certainly have, in our first data set, assuming that these are in the same units of measurement, we almost certainly have a higher outlier or a higher skew in this first data set than this second one, because the mean 15 is further away from the median of 10 than the mean of 12 is from the median of 10. And that is supported by seeing that standard deviation and variance are larger for this first one than the second. And remember, measures of variability tell us how spread out our scores are. So if you have scores that are spread out and you think there's an outlier, that would make pretty good sense. Over here, on the other hand, we just might have a regular kind of a distribution. The mean is higher than the median. Maybe there's not an outlier. Maybe there's a slight skew. We can't really tell. But we can certainly say that this one is more likely to have a high outlier or skew than that one. We're going to need to have an understanding of how to describe our data. And so we're going to go over these in pretty painstaking detail, and this is a really good thing to bring up in class. So now I want you to work out some problems. We're going to go over some of these problems in class. If you can do them, wonderful. You can check your scores when you get to class. And if not, then bring them and we can work through some of them in class as well. So in this case, I just want you to give me all 5 of the all 6, measures of central tendency and variability. We have another one here where you have a population of 15 students and have these height measurements. And I want you to tell me all of them as well. And I also want to talk about what this means. So I'm going to give you a group of scores. So we have group A and group B with means and medians, variances and standard deviations, C and D, E and F, G and H. And I'm going to want you to compare each of these. So A compared to B, C compared to D, E compared to F, G compared to H. And if you are able to do that, then you will show to me that you fully understand how mean, median, mode, range, standard deviation, variance, how they work together to describe a data set. But again, I expect this is something we will go over in more detail. And then the final problem. Here I'm asking you to see if there's a difference in happiness between people whose favorite numbers are single digit and those whose numbers are double digit. What do you think? This is the type of question that is difficult. I expect it would take you some time. If you can work through this problem and you get it right, I'm pretty sure that you will be just fine on the test. This is kind of the last gauntlet problem. But I also want to let you know that the problems on the test are not going to be as hard as this one. So this is almost like we're over practicing. We're working towards something that's even harder than what you're going to be tested on. So where should you be right now? You should have the difference between, you should know what measures of central tendency are and be able to contrast them to measures of variability. You should be able to calculate mean, median, mode. You should be able to calculate range. You should have at least tried standard deviation and variance and have an idea of how they work together. If you are able to do that, come to class with your problems, your questions. I'm fully convinced we can knock this out in the next week or so, and you'll be shocked how quickly you will be able to do all of these problems.